Welcome back. In today's video, we're going to talk about these 3D printed face shield frames, how they work, what's so special about exactly these, and how you can print them super fast. I've got a ton of cool 3D printing tips and tricks for you, many of which apply to 3D printing in general. Thank you so much for joining me in today's episode. Let's get started. So I'm sure you've seen by now, 3D printing these frames for face shields has become a big thing in the maker community. And it's really cool to see so many people across the world coming together using their tools and knowledge to help out the healthcare workers, which seem to be suffering from a global shortage of personal protective equipment. So there's actually quite a few different designs for these face shield frames, but they all more or less do the same thing. You have this one here from Prusa that uses buttonhole elastic to hold onto your head. This one here from 3D-verkstan that uses this springy type geometry to clamp on your face, and they both use some sort of pins to hold a clear plastic sheet as the face shield part. And then there's this design, which I want to show you in this video. This design has been developed by the local community here in Norway, and it's been an evolving design developed with the feedback from healthcare workers and with the aim to be able to print as efficiently as possible. And I consider myself very lucky to have been able to be a part of this project. Now, it works in much the same way as the one from Prusa. It uses elastic to hold onto your face, but it has a slightly different geometry for the frame itself. The pins that hold the plastic in place are also slightly different, and it can be used with a bigger variety of elastic bands, but we'll talk about these in just a second. Before we go any further, I just want to say how proud I am to be able to be a part of this maker community, and especially here in Norway, where the community has been able to print, assemble, and distribute over 30,000 face shields like this. So if you live in Norway and you want to help out, I'll leave a link down below to a Facebook group that you can join if you want to help out either printing, assembling, or distributing face shields like this. And if you live in Norway and you want to help out financially, I'll leave a link to that one as well. All the money raised for this will go to covering the material costs to make these, and they will all be given away for free, just like the first 30,000 have. And if you live anywhere else in the world, check out your local community. There's efforts going on everywhere, and I'm sure your help will be greatly appreciated. So let's have a look at this face shield frame that we've designed. Oh, and by the way, I'm not saying that this one is a better design than any of the other ones that I've shown. They all work great. This is just the design that we've come up with and that suits our needs. So this frame, just like the other two that I've shown you, has 4 pegs in the front to hold a clear plastic sheet that will act as the face shield. The geometry on these is designed to hold the plastic film securely in place, as well as being able to print without needing any supports. Now the placement for these pegs is very important, because we'll need to make 4 holes in this clear plastic sheet that matches with the holes on this frame. Now making these holes is actually super easy. The only thing you need is a standard hole punch, because the holes that we're going to put in this are a standardized hole punch size. The standard is called 888, and it stands for 4 holes spaced 80 millimeters apart. So if you have one of these hole punches, you can use that one to make the holes. There's usually this little tab here that will say 888 on it that you can use to align the paper like this, make a hole, flip it around, and then make 2 holes on the other side. Now I realize that in many parts of the world, this European style hole punch is not a standard, but you should be able to use any normal hole punch and then just measure up 4 holes with the right spacing. Moving on to the side of these frames, there's a variety of different options of elastic to be used on this side. You can either use the standard buttonhole elastic that will go onto this little ear here, just like the one from Prusa, but this version also has these 3 holes in the side. And these 3 holes allow you to use a bigger range of these normal flat elastic bands. This 10mm elastic band seems to be the ideal, and the way you thread it in is that you go in from the inside of the first hole, go out through the frame, come back into the second hole, and then back out through the third. And then just to make sure that everything is locked in place, I would go back through the hole that you came from originally. And that way everything is nice and securely in place. Now this also works with thinner elastics, threaded the same exact way. I would just recommend putting a little knot at the end to keep it in place. And it also works with bigger elastics, just like this. I only threaded it through the middle hole from the inside and then back through the back hole, and that kept it in place just fine. Oh, and I would also recommend putting a little soft padding on the inside here, because people are usually going to be wearing these for like 10-14 hours a day, and it can get a little bit uncomfortable with this plastic rubbing against your face. All right, so let's have a look at how to print as many of these as quickly as possible and as easily as possible. So I printed hundreds of these frames, and I spent the last couple of weeks testing out all sorts of different settings and speeds and trying to figure out what sort of differences things like different printers, nozzle sizes, layer height, or movement speed actually have. So we'll start with the general things. Easy changes that apply to all 3D printers, stuff that will increase your efficiency without having to fine-tune a ton of settings. And then for those of you who want to optimize your printers even more, we'll go into a bit more detail as we go along. Quick reminder though, everything you're about to see is using PLA as the plastic I'm printing with. PLA is a great plastic, it's quite chemically resistant, but it doesn't like high temperatures that much. If you need that, you can definitely print these in ABS or PETG. A lot of the tips and tricks that I'm about to tell you will still apply. The temperatures and speeds probably will be off though. Okay, let's clean this up. I'll get my computer and then we'll have a look at how to print these as fast as possible. Okay, on to some tips and tricks. Tip number 1, print in stack. Okay, so first things first. This design specifically is optimized to be able to print in a stack. That means that we'll print a whole stack of these at once and then we'll separate them once they're finished printing. And as I mentioned earlier, the geometry of the design is optimized so you can print these without any supports. That cuts down on printing time and it also cuts down on cleanup after effect. You'll literally just rip them apart and here you go, another frame. And generally speaking, if you do nothing else than switching from printing 1, maybe 2 at a time to printing a stack of these, you're gonna save a ton of time because you don't have to restart these every few hours and you can let this thing run overnight. So in order to be able to print these in a stack, we need to switch to the right layer height. And switching layer height, even if you just print 1 at a time, will also help you speed up the print time. So we'll jump into Cura right now, which is the slicer that I'll be using for all these examples. If you're using a different slicer, most of this will still apply. The buttons just might have different names. Okay, so let's start with importing a model of just 1 frame, just so we have a baseline to compare our improvements to. We'll use the standard settings, set this thing to as coarse as it will go, and maybe 50% infill, and that will give us 2 hours and 36 minutes to print this thing. Wow, that's a really long time to print one of these. But just for fun, let's try and import the other 2 designs and see how long those would take to print in the same settings. So the one from Prusa would take 4 hours and 54 minutes, and the one from 3D Verkstan would take 1 hour and 49 minutes. So quite a big range, but in my opinion, they all take a really long time to print. And keep in mind, a lot of the things that we'll talk about now will also apply to the other 2 designs. Okay, so now let's import a 10 stack of these and see how long that's gonna take to print. And wow, would you look at that? It says that it's gonna take a full day to print 10 of these in a stack, which, like we just talked about, would still be faster than printing 10 individual ones, 1 at a time. But like we mentioned, there's one setting that we have to change in order to print these in a stack, and that is layer height. So this model is designed to print with 0.3 millimeters layer height. And regardless what printer you're using or what nozzle you're using, you'll always have to use 0.3 millimeters layer height. Because that is the height of the gap in between these frames that allows us to rip them apart after they're printed. And look at that, changing nothing else, the print time is down to 12 hours and 44 minutes. So already half the time. Next tip, nozzle size and line width. So here's the thing that might be a bit specific to your printer. We've changed the height of the line. Next up is the width. We can change that regardless of the size of the nozzle, but there's a limit to how much plastic you can squeeze out through that nozzle. So naturally, a bigger nozzle is gonna be better because you can squeeze more plastic out of a bigger nozzle. So if you have the ability to switch to a 0.6 or a 0.8 millimeter nozzle on your printer, that's gonna help you out a lot. If not, there's still a lot to be gained from having a look at the line width. So this design is made specifically for a 0.8 millimeter line width, because all of the geometry on this frame is exactly 1.6 millimeters wide, which is the equivalent of 2 lines of 0.8 millimeters. Or if you're using a 0.4 millimeter nozzle, 4 passes with 0.4 millimeters. So naturally, 2 passes with a 0.8 millimeter nozzle is going to be quicker than 4 passes with a 0.4 millimeter nozzle. With nothing changed, the printer would do 4 lines and then try to fill the gap between those lines, which is super inefficient, and that is because the default line width for the 0.4 millimeter nozzle is actually 0.35 in Cura. So we'll set that to 0.45. The reason why we set it a bit over 0.4 millimeters is that the lines have a bit of an overlap for a stronger print. And if you can't see the options that I'm talking about, you can click on this little gear icon and select the option that you want from the menu here. Now with just changing the line width, the print time went from 12 hours and 44 minutes down to 9 hours and 31 minutes. So we're really making rapid progress here. Now, you can imagine where I'm going with this. If you change to a 0.8mm nozzle and then set the line width to 0.85, we're down to 8 hours and 22 minutes. But keep in mind, these numbers are still just an indication of how fast we can actually print, because the speed at which you can move the nozzle varies a bit from nozzle sizes and between printers. But we'll get back to that in just a second. Lastly, here's a cool trick for you. If you only have a 0.6mm nozzle, you can also set the line width to 0.85 and just squish out more plastic. You have to watch the print speed a bit because you're trying to squish more plastic through a thinner nozzle, but on many printer, a 0.6mm nozzle can be just as good as a 0.8. Next tip, print speed. Now this was definitely one of the most time-consuming ones to figure out, because the print speed varies depending on how quickly you're able to melt the plastic and how big the nozzle is. As an example of this, my Ultimaker 2 Plus with a 0.4mm nozzle can print at roughly 80mm a second. But with the same printer with a 0.8mm nozzle, I can print 60mm a second. But that is just because the hot end has to work less hard to melt the plastic, because the hole at the end is bigger and has less resistance. Now onto my Sidewinder, which is my second printer, which seems to have a slightly more efficient hot end design. I was able to print with the 0.4mm nozzle at 80mm a second. But on the 0.6mm nozzle, setting that to a 0.85mm line width, I can still print at 80mm a second, which is literally twice the amount of plastic that you're pushing out at the same time. So as you can see, different printers might vary a bit, but with all these examples, you should have a good starting point for your printer. So let's try this out. So from testing, I know that with the 0.4mm nozzle, I can print 80mm a second on my Ultimaker. So let's set everything here to 80mm a second, with the exception of the initial layer. We'll keep that at 25. And we'll keep that at 25 across both printers and across all nozzle sizes, just to get a really solid first layer. Now we get the print time down from 9 hours and 31 minutes down to 5 hours 52 minutes. And on the 0.8 nozzle, I know I can do 60mm a second, and that will give us a print time of just 4 hours and 12 minutes. Oh, and on the Sidewinder, with a slightly different hot end, I can do 80mm a second with the 0.4 nozzle, which is 8 hours and 29 minutes, but I can do the same speed with the 0.6 and the 0.8mm nozzle, which both give me a print time down from 8 hours and 29 minutes to 5 hours and 55 minutes. And keep in mind, there will be different times between the two printers. There's still some settings that we haven't looked at yet, as well as there will be things like acceleration, which will be different between the two printers. Also, you can usually set the travel speed a bit higher than default. On my Ultimaker, which just has a lightweight moving head, I set that to 250mm a second. On my Sidewinder, which has a moving bed, I set that to 150. Next tip, temperature. The right speed is key to get a fast print, but to get that speed, you have to have the right temperature. I found that 230 degrees Celsius is a good starting point. It's fairly high, but we're also trying to move a lot of plastic. Your printing temperatures might vary a little bit based on the plastic that you're using and how fast you're moving, but 230 is a good starting point. For my 0.8mm nozzle on my Ultimaker, I use 220 degrees C, and for all the other nozzles on all the other printers, I use 230 degrees C. So on any other printer than on the Ultimaker, in Cura, you should be able to go in here and change the temperature to whatever you want. On the Ultimakers, you can either change the temperature once you've started the print from the menu on the printer, or you can enable that setting in Cura. To do so, you can either go into settings and change the G-code flavor to Marlin. This, however, will change the startup sequence of the printer. So you might need to just copy and paste this from the link in the description below into this little box right here. Or another way you can do this is that you can just import one of these files that I've linked down below and then open them as a project. And it will have that setting enabled together with everything else that you need. For this to work though, you have to have the right version of Cura. I'll make sure to leave a link down below to which version of Cura I used for which projects. Next tip, shell and infill. This is where we set the amount of lines the printer is going to do around a part before it's going to start on the infill. And on this part, you don't need any infill, so set that to 0. As for the shell, remember we talked about the printer needing to do a certain amount of lines to cover the thickness of this part, so the shell line number is going to be the exact same number. So for the 0.4mm nozzle, we'll do 4 lines, and for the other two, we'll do 2 lines. That way, everything in the model will have the same thickness and everything will have the same strength. These little ears on the sides will be hollow, but that's totally okay. Also, I set the bottom layers to 0 and the top layers to 5, The only thing this will impact is the top of the ears, which will be nice and solid, and otherwise there's none of what you would consider bottom layers in the model. Compensate wall overlaps. So this button changes the width of the line to compensate for that little bit of overlap you get from setting the line width slightly higher. Now for my Ultimaker, I had to uncheck this box so that it wouldn't compensate and make slightly thicker lines. On my Sidewinder, I left that option checked and didn't do anything more about it. Now sometimes what can happen if you're printing really fast is that the lines don't connect properly and separate after the fact. With the 0.4mm and the 0.6mm nozzle on my Ultimaker, I just unchecked that box and it was fine. And with the 0.6mm nozzle on the Ultimaker, I also increased the line width to 0.9mm. Next tip, build plate adhesion. Glue stick, glue stick, glue stick. Just regular old glue stick that you used as a kid in school. This thing will save you for so much time and trouble. A liberal layer of this stuff on the print surface before you start printing will make sure that the print sticks properly to the build plate, but that you can also remove it with relative ease. You can use this stuff either with a heated or a non-heated build plate. I use this stuff on my glass build plate on the Ultimaker, even on the textured one on the Sidewinder. If you use a glue stick, you can turn off what is called build plate adhesion. So normally you have 3 settings to choose from. You can either use brim, raft, or none. And depending on what you're using now, this can save you up to half an hour of printing time. Glue stick, it's great. A few quick settings. Let's run through a bunch of random settings that I have on both the printers and all the nozzles. And for the settings I don't mention here, just leave those at default for now. Optimize wall printing order, off. Outer before inner walls, off. Fill gaps between walls, everywhere. Print thin walls, off. Filter out tiny gaps, yes. Seam corner preference, hide seam. Combing mode, off. And no supports. So let's see where we're at. With all those settings, we go from a default 1 day and 52 minutes on the Ultimaker with the 0.4mm nozzle to 5 hours and 51 minutes with all the settings for the 0.4mm nozzle, and just 3 hours and 56 minutes with the 0.8mm nozzle. And that's just about 24 minutes for one of these frames, which is roughly 6.5 times faster than what we started out with. Pretty good, huh? And on the Sidewinder, we get a print time of 6 hours and 58 minutes with the 0.4mm nozzle and 4 hours and 1 minute with the 0.6 or 0.8mm nozzle. Adhesion between parts. Okay, so we've so far gotten the print times down a lot. Now we just need to make sure that the prints actually come out all right. And the main thing to watch out for is that one frame will print properly on top of the next frame. You want it to get just stuck enough to be on there properly, but not too stuck to the point where you can't remove it after the fact. Now on the bigger 0.6 and 0.8mm nozzles, this has generally not been that much of a problem. But as a rule of thumb, if the prints gets too stuck together to where you have a hard time to rip them apart, try lowering the printing temperature with 5 degrees C increments. If they don't get stuck together enough to the point where they're starting to be a little bit stringy on the inside here, try increasing the temperature in 5 degrees C increments. With the 0.4mm nozzle, this can be a bit more challenging, purely because of the fact that there's more lines that need to connect on top of each other. On the Ultimaker with the 0.4 nozzle, this was never an issue. But on the Sidewinder, and from what I heard on a lot of other printers with 0.4 nozzles, this can be a little bit of an issue. And the solution for this is to slow down the print speed a bit as it's printing the first layer of the frame above. Now in Cura, you can do this by setting the bridge wall settings. I'll set the minimum bridge wall length to 2, bridge wall speed to 35, and bridge fan speed to 50%. That makes the plastic a bit more sticky and gives it more time to connect to the layer below. Next tip, holes. Now this is where it starts to get a bit more specific to each printer. The Sidewinder didn't have any issues with the holes whatsoever. The Ultimaker, however, struggled a little bit to get a nice finish around these holes. Now I think a lot of that has to do with the Ultimaker having an external extruder that pushes the plastic through a Bowden tube, versus the Sidewinder, which has a direct drive extruder that pushes the plastic a much shorter distance and is able to retract that plastic much faster. So I'll show you how I fixed this issue on my Ultimaker, but it might not be a problem on your printer. So on the 0.4mm nozzle on my Ultimaker with the higher speeds, the finish wasn't great. So I wanted to slow down the speed at which the nozzle prints those little features, which is a standard thing you can do in a lot of other slicers, but for some reason, Cura doesn't have that feature. So here's where it's gonna get a bit more tricky. I had to download a custom version of Cura, which I'll link down below, that had this enabled. And after installing that, importing the model, putting in all my settings, everything looked great. Now this setting is called small hole feature. I'll set small hole size to 10, small hole feature speed to 30%. That will slow down the print speed of those small features to 30% of the maximum speed on any segment below 10 millimeters in length. And that fixed it. And with the 0.8 millimeter nozzle on the Ultimaker, I had a similar problem where I was just moving so much plastic that the printer was just over extruding those little segments around the holes. And the feature that I found works best to eliminate this on the 0.8 millimeter nozzle is called coasting. Now coasting is when the printer stops extruding a little bit before the end of the line, and the remaining pressure in that Bowden tube will force the plastic to be extruded out. Now this is a default feature in all versions of Cura. The weird part that for some reason Cura doesn't want to apply that feature to those small segments in any of the Cura versions I had installed already. But in the version I just installed to get that small hole feature, worked just fine. So I can highly recommend that customized version of Cura. So far it's been working great. So I set the coasting volume to 1.5, minimum before coasting to 1.5, the coasting speed to 50%, with the small hole feature turned off. And this worked pretty well. However, the Sidewinder with its direct drive extruder still did a little bit better of a job. And just because you can print at 60 millimeters a second with a 0.8 nozzle here, doesn't mean you have to. You will get a nicer finish on 50 millimeters a second. Now, this was all the settings and all the tips and tricks I had for you in this video. So now let's have a look at the final print times with all these settings applied for the two different printers. On the Ultimaker with the 4 millimeter nozzle, we're down to 6 hours and 46 minutes. With the 0.8 millimeter nozzle, we're down to 4 hours and 7 minutes. On the Sidewinder with the 0.4 nozzle, we're down to 7 hours and 4 minutes. And on the Sidewinder with the 0.6 or 0.8 millimeter nozzle, remember, they're both the same, we end up with 4 hours and 7 minutes. So funny enough, the exact same time on both printers, even though we were printing at different speeds with different features enabled, and that was just a coincidence. So I really hope that this video helped you out. I hope that you can now get starting printing these frames and hopefully printing those with great efficiency. I also want to give a huge thank you to everyone that has made this possible. There's been a lot of people working on this design. And I also want to thank AdNorth, who reached out and actually sent me a couple of rolls of filament that I turned into these face shield frames. Thanks guys, your filament worked great. So thank you all so much for all the hard work that you're putting in. I'll make sure to leave links down below to where you can download these, and I'll make sure to include versions that have different amount of frames in the stack so you can print as many as you want. I'll also include the Cura files for both printers with all the nozzles I've used. Just keep in mind, for some of the settings to work, you need to have that special version of Cura. As for now, thank you so much for watching. I hope you enjoyed this video. I hope it was useful to you. And if you know someone that would benefit from watching this video, maybe you can share it with them. And if you liked the video, please give it a thumbs up. It actually makes a huge difference if you do. If you're not yet, please subscribe and please stay safe. And I'll see you guys in the next video. Thanks for watching. Bye bye.